Hi. Okay, Christian. I'm lead developer of the Raspiblitz project and active in the Berlin, Germany kind of Bitcoin scene, and connected to Fulmo. Maybe we did a Lightning Hack Days. I will show you a little bit soon. And my topic is mostly like building a Bitcoin full node and a Lightning node on a Raspberry Pi. So we'll give you a little bit intro today on that. Just why we're here is all about the Lightning network. And of course, all you know is Lightning is a payment network that is kind of built on as a second layer technology on Bitcoin. To make it simple for people, it's like more like compare Bitcoin like your bank account. It's a little bit more static. And the Lightning network wants to be more like a payment network for everyday payments, small payments on top of Bitcoin. But it's acting with real Bitcoin that are locked on the based blockchain. So a little bit history on the Lightning network. It started about over a year ago, and the basic kind of benefits are instant payment, so you don't have settle time from 10 minutes or something, so it's very settled very quickly. It's micropayments, so you can send very low kind of amounts over the network. It's extremely low fees compared to what you have on the main chain, so you can send value around for just Satoshi kind of fee value, even maybe lower if you find a good route. It's privacy enhancing, so because it's not every transaction is not on chain, you have the transactions off chain, so not every transaction gets recorded on the blockchain, so it enhances your privacy. And even within the network, within the payment network, there are measures to so that not everybody can see every route that's happening and every payment that's happening. There's massive scaling potential with the Lightning network. So at least theoretical, we say a payment channel can do round about 500 transactions per second, just one payment channel, and Lightning is a network of payment channels. So you can see there's a lot of kind of scaling possibilities there. And this is how we want it. It's also like Bitcoin, an open source peer-to-peer network. There's not a central authority by design. There can be maybe if we built it lazy and we just connect to one node, of course, there can be something that can look centralized, but the protocol itself allows us to build a very decentralized network if we really want it. And I have to go. All right, so this, when this all came out, it sounded very exciting to us because it was the area where Bitcoin was the big hype, the fees were going up, and then we were seeing, we heard so much about the Lightning network, and now we were seeing first prototypes coming out and getting closer to mainnet, and we were saying, come on, that's cool. Let's gather together in Berlin. We started the Lightning Hack Days. And as you can see, as you were seeing, like we had Raspberry Pi sitting there from the beginning because there was this great tutorial from Staticus, like just a kind of follow step-by-step tutorial how to set up a Lightning node, a Bitcoin full node and a Lightning node on a Raspberry Pi. So we said, come on, get some Raspberry Pis, let's experiment with that. One takeaway on this Hack Days was, this takes a long step, like going through every little step in the tutorial takes really a little bit of time and you can make errors. So it was not that perfect for such an event to do.
I have a question. How did you manage to buy so many Pis at once? That's a big problem.
No.
You can only buy one per account. So.
Really? On Amazon, you can really, I think up to 12 I can order in Germany. Maybe it's different in other countries, not sure. But we were able no problem, get 10, 15 Raspberry Pis together in a kind of breeze. So, yeah. And we were seeing it takes a long time to set it up. So the takeaway from the Raspiblitz kind of side was we have to make it easier to set up this and build maybe. And I was thinking, these are some steps. Why not we just putting it all into a shell script and providing the shell script to the community? And this is a bit how the Raspiblitz project got started. And from there, more and more we got into making it better. So mid last year, so a year ago, we were already seeing Lightning was gaining a lot of traction. We were seeing people love to experiment with it. People were setting up nodes, and we see the network growing. First of all, in those kind of images you see, not every node is visible. Those are more the routing nodes that are visible in those graphics. So there's a lot of more nodes at the end connected to this network. Lightning is also not Bitcoin exclusive. So there's also a Litecoin Lightning network that is available through LND implementation. A lot of people started to run nodes behind Tor, so to gain a little bit privacy. We will see a little bit later then what that might imply. We had around about this time, we had this kind of first big app, the Satoshi's Place, where we really had this one page where you can really pay 1 pixel to paint 1 pixel on the website. And we were seeing like people using this a lot. So we had the kind of first stress test of the network, what was quite nice to see that a lot of stuff is working there. So the direction was correct to go forward. And we were seeing that the first even mobile wallets were kind of starting to developing to that you can connect to your node. So of course, because normally you had this full node running on your computer, so of course you want to have it on your mobile phone somehow to be on the road and be able to pay in everyday life later on. So the third hack day already kind of got a little bit bigger that we did in Berlin, and as you can see, we already had the Raspiblitz thing a little bit more worked out, still in a kind of very early phase. And we were seeing that people really started a lot of experimenting and building and hacking out stuff, trying out the Lightning Network. We had this great kind of photo machine from Staticus who was joining. And even the press started a little bit to see, oh, there's something going on with this Lightning Network, and reporting on that. And yeah, as time goes by, this is just 2 months later, you can see already the channels and the network was growing. So this was kind of a constant thing we were seeing. And because the Lightning Hack Days had so good kind of response, we were asked, well, hey, would you like to come over to New York City and do a hack day there? It was very interesting for us to see if it's just a German thing we had in Berlin, or if it's something we can even see in other countries. And the good thing really was there, the spirit was there, the kind of community had the same kind of excitement, and it was a great time and for us to see more and more people joining this kind of interesting technology and going ahead. So the Lightning Network was growing, so we now count about in October last year. Then there was coming up the Chaos Communication Congress was happening, and we always have a little Bitcoin assembly there. And of course, Lightning that year was a topic. And we're seeing people experimenting a bit, like at least the Bitcoin satellite, not exactly Lightning, but people were experimenting with that. We had this little e-scooter where somebody was building a e-paper and a little node connection there, so you can really just pay with Lightning and then you can the electricity was turned on and you can ride with this e-scooter. And we were seeing kind of, this was the hack day. The funny thing is this picture I really like from Peter Todd. He said he never was seeing so much full nodes at one place. So maybe some kind of centralization, but this was part of a workshop. So people were building. The first time we did a Raspiblitz workshop with people in a kind of bigger scale. So people were really putting these things together, and then they were sitting on this table, syncing up and getting prepared. So this was a great picture to look at. So, and we were also seeing kind of first prototypes from Stefan Signerev, the hardware wallet. So always kind of starting to thinking how we can improve security for Lightning nodes. And the first was seeing like the first prototype of the flux capacitor. Ben will show you later on a bit what's that about. Yeah, we see more and more growth in the network. And after a while, not long ago now in June, we did the hack day in Munich. And we really had we were seeing, this was then the hack table there. You can see already a lot of projects kind of stacking up where people were experimenting with. And we had some nice thing, for example, a beer tap that you can pay with Lightning. So it was a great success. People loved that, especially in Munich. So beer in Munich, that works. And we had this interesting thing of a prototype of a Lightning ATM built in Lego. That would even work when the machine itself is offline with a little trick setup, but we'll not go into detail there. But Lightning ATMs are possible, so at least there are prototypes and everybody wants to look at it. Feel free and let me know. So Lightning Network was growing and growing, so this is kind of the last stage we had from July now. We can see like over 34,000 channels are there. We have almost, not exactly, but almost 1,000 Bitcoin people have in their payment channels available. And there was a little bit, I think over the last months, there was this, I think the Lightning Network was a little bit kind of reducing, like some channels were going away. This could be because the price of Bitcoin was rising again. So people were saying, oh, now before it was maybe $20 you were putting on there. And then of course it got more and more. And then you maybe put some Bitcoin out there because it's a hot wallet, there's a security risk. And so people consolidated, I think, a bit the structure. What is good to have sometimes even when you really think about what channels I like most, how much funds do I really want to have in there.
You got private channels and stuff too now, and that's
yeah. So not everything is visible anymore. People are experimenting with having routes that not everybody can see. So just don't take this number as always the truth at all. But this is the visible part you can see, and that we can publicly analyze. If anybody wants to check out Lightning nodes in detail, there's a search engine, 1ml.com, where you get the latest stats and you see really a directory of public Lightning nodes if you're interested for further details.
How do you generate that graphic? I've seen that graphic tons of times.
This is a website called Rexplorer, Rexplorer. I can maybe give you the URL later on. You will find it if you search on the internet. There's a lot of different kind of visualizations now even, so I just stayed with this one because it was very early on available and it keeps consistent over time. So yeah, and what we were seeing, so I showed you the Raspiblitz was something we did during the hack days, like developed out there, but we were seeing that even beside the hack days, people were so interested in that, wanted to build this at home, really over a weekend or something, take it as a kind of project to try out. And this was showing us that there's a lot of interest in now building really your own node and running your own node. Because of Lightning, there was a lot of interest, but Bitcoin is a base you're building on. So the best thing is also to run a Bitcoin full node. So we were seeing really people, we were getting very interested again, running full nodes, Bitcoin full nodes themselves, and then having a Lightning node on top. And the Raspiblitz, a little bit more like a do-it-yourself project. Of course, there's some other options that people are available if you want to get a little bit more professional. For example, very early on, there was the Casa node, the Casa HODL, I think which is now a little bit more integrated into their kind of multi-signature kind of business model to have your Bitcoin secure. It's a little bit part of a startup strategy over there. Was round about an investment of $300. Then there's also Raspberry Pi in there and the hard drive, so just a nice case. And there is the nodl you can buy if you really want to go a little bit more upscale. Like I always like to say, it's a little bit the Mercedes of the nodes out there, because they make very good support. You get a tested hardware set, and there's a ROC 64 in there, so a little bit more powerful hardware than the standard Raspberry Pi we had over the last months. And then there's in development, there's the Bitbox base. That's the Shift Crypto company from Switzerland, and Staticus, who was making the original tutorial I was building the Raspiblitz on, this is his kind of project to work on there, to build a little bit more also professional focused node. Just to give you a little bit differentiation, the Bitbox base is running C Lightning, so there are multiple implementations of the Lightning protocol, multiple clients or implementations, and most of them here you see are based on LND from Lightning Labs. The Bitbox base will go with, as far as I know at least, will go with C Lightning. So if you're a little bit more into C Lightning, maybe the Bitbox base is something to watch out for in the future. Yeah, but as you can see, to compare it with the other nodes, the Raspiblitz is not the idea to build a startup around, like giving you, like selling you the Raspiblitz. We have now even a shop where you can get it pre-assembled, but it's more just for convenience. The idea is really that you can build it yourself for around about $150. So it's like the cheapest entry into that, but also expect always a little bit the entry level here. So if you're really looking for a more powerful or more professional customer support, you may consider the other nodes here on the picture. So this is one for the people that really want to tinker, that want to learn, that want to educate, and then have fun really at one point also running as a sovereign hardware at their home. By the way, all the nodes as far as I know are open source, but the Raspiblitz has the more besides a community approach to build this up. So what is the Raspiblitz? You can see this beautiful picture over there. So in the end, you see it's an LCD screen on top. There's then the Raspberry Pi with a casing on there, and there's a hard drive that is sitting below. I can give you this one here just to show around. This is the kind of basic setup we had until now. I will show you the improvements with the Raspberry Pi 4 a little bit later. But this is kind of the basic setup you need. The LCD is not a very it's not essential. Or maybe it is essential, but you can run it without the LCD. But the LCD has shown to be a good feature to show people stats and help on the setup process. And I think it adds to the look of the device too. If you go to the GitHub page and you want to start this and do this at home, for example, there are multiple shopping lists available. So Amazon is just one of the main provider, but of course there are other shops out there. So you find on the GitHub page, you find for different countries, for mostly community managed lists where you can just go there, put it into your chart, order them, and then you have all the hardware you need to do your project over the weekend. So yeah, and so as you can see, that's a kind of basic setup to go. So what people then do, this is not my Raspiblitz, this is what somebody was sending over Twitter. As you can see, people see this as part of their home internet infrastructure, like putting it next to your router. That's a good place. Also, the best way is to connect it over Ethernet cable for good, stable, and fast internet connection. You can connect it with Wi-Fi too, because the Raspberry Pi is available or is able to do Wi-Fi, but I would always kind of advise to do it over Ethernet cable. Yeah, so it's an always on device, so just really expect it if you set it up that it will run all the time. And a little bit of warning, it's a hot wallet. So if you put funds on there, so even if first of all, you put funds on there on chain, the LND is managing a Bitcoin wallet for you. So then you put your funds into that on-chain wallet, and then from there you open your channels into the Lightning network and put the channels, the funds into those channels. And it's always sitting in this or managed by this always on device. So I think it's a hot wallet. You have to be a bit careful there. Maybe in the future we'll see something like the hardware wallets for Lightning, so you get a little bit more security. So just to be warned, don't get too crazy with the funding for this device. I think you can, with about $20 or something, you're like in that area, you're good to experiment and make your first experiences. After you get a little bit more experience, maybe you can get a little bit more reckless, but be careful. So I just wanted to let you know. There's from the power side, and that's the good way we have it on a Raspberry Pi. It's about 5 watts. So for my electricity kind of builds, it should be about 12 euros a year just for the electricity. So it's not a big investment to have it really running all the time, and not a big energy waste compared to some other stuff you have around, like in your home for running. Yeah, the LCD is always a good thing. People like it. There may be an e-paper option in the future. We can see a little bit how this works later. But the most interesting thing is people ask a little bit, why should run a full node? Because now, when we see now, you can even have a Lightning wallet now on mobiles that are not a really full node. There's not a Bitcoin full node behind it. And the thing is, if it's not your node, it's not your rules. Somebody else is checking all the Bitcoin rules for you, and you're entrusting somebody, not with your funds especially. You have your private key, your funds, you control it, but the rules around the network, how the Bitcoin network works, somebody else making this decision. For example, when a fork is coming in the future, maybe, and somebody else is running the full node for you that your mobile wallet or light wallet is just connecting to, then those people will decide which fork to follow and not you. So a little bit, this is the thing, you run the complete software stack if you run a Raspiblitz. There's really a Bitcoin full node, a Bitcoin Core full node running, and there is then the Lightning, the LND Lightning on top. So you're in control, you're running really the complete stack, and it's your decision which way to go if there's any decision to make in this peer-to-peer network. How do you start then? Okay, you have all this hardware, you put it together, and this is what the LCD would show you like in the beginning. So it will say, oh, please now SSH in, and it shows you the IP address. So it shows you the complete command you have to put into your terminal, and the default password in the beginning. You will change, of course, this password later on. And then you open your terminal. Not everybody is kind of used to using a terminal. So there's on the GitHub page, there's a little bit introduction if this is the first time you're opening a terminal. But don't be scared of the terminal. It's just a gateway to the Raspiblitz, and you will be more easy on after that. But the good thing is, in the beginning, if you at least know where the terminal is, and you SSH into this Raspiblitz, it's like really logging in onto a server like that you would run anywhere else on the internet. So we're really learning a lot, kind of how you manage a server, or you at least free, or you have the gateway already to learn a lot if you want. And a quick look at the GitHub repository. That's over there's the address of the GitHub. If it's too long for you, you can also just punch in raspiblitz.com, and there's a link to the GitHub. So just wanted to let you know when you first see the files there in the GitHub repository, what can you find there, and maybe even if you want to contribute, where can I start, where can punch in a bit. You can see there is, of course, the README. The README is a good start for you, really. There's the whole tutorial in there, how to set it up and how to get started. Then there's the FAQ, where you find more detailed information for special questions. And there's even a workshop documentation there for people that are thinking about using the Raspiblitz in a workshop environment. So all these are open for contribution. For example, if you do a workshop and see something to be improved, please feel free to make a pull request, or at least send me an email what can be changed, and I'm very open to that, to improve that. Then the most important kind of directory you find in here is the home.admin. And this is the folder in the GitHub repository where you have the main setup scripts, and they are mostly numbered, so you can see kind of a little bit on in which priority they are executed. So you can take a look at those if you want to know something about the setup in the begining. Then there are menu and the helper scripts are there, and the background and recovering for updating the Raspiblitz. All those are in this directory, and normally if the SD card gets built, those directory gets copied into the admin user directory, and the admin user is the normal user you're logging into the machine. What is also on there, and it's not seen there, but in the main you have also the SD card. So if you're very curious and you don't trusting the image you use to set up the Raspiblitz that I provide on the website, there's a build script. So you can really build, you just take a plain, clean Raspbian from Raspbian Foundation, you run the build script, and it will kind of build this SD card to install. And you can, maybe if you're really curious what's happening there, you can take about half an hour, maybe look through this build script and see if there's anything installing at this point that you don't like and you don't want running on your machine. So just to let you know, you can build your own SD card image there. Yeah, and then there's just this one folder to mention, at least the config scripts. Those are a little bit more like the little tool scripts. That's sometimes those scripts you call to turn on and off special features on the device, or set special configs in the system. So if you're searching for really just little hacks, maybe sometimes this is a good directory to get in there. So how does it look once I have set up my Raspiblitz? You get, in the end, when I SSH in, I get this kind of menu here. So during the setup process, it looks very similar. You get little kind of dialogues. Those are happening in your terminal over here. And what you see over here is the information screen you see on the LCD. So, and always on the LCD screen, you find the information how to log in. You see the SSH command there. So even if you're a little bit forgettable or something, you just look at the LCD screen and you find the idea. You set some passwords, those you have to remember. And also, of course, you're setting up an LND wallet, so you have to write down your seed and put safely away in the case you want to recover at one point. So let's take a quick look what you find in this screen over here. It's because this is kind of the main menu how you operate your Raspiblitz. There's some information thing. This is in the end the same screen you can get over here. And here you see a little bit how you go step by step. First of all, you have to do funding. You have to transfer Bitcoin onto the Raspiblitz if you want to open then channels. But before you open a channel, you connect to other peers. So before I make a channel with somebody else, I have to add those person at the peer, because it's a peer-to-peer network just for communicating. Just adding a peer is not costing you anything. It's just building up a communication channel to somebody else. Once you have this communication channel to somebody else open, you can negotiate opening a channel. So then you have now funds on your Raspiblitz. You now connect to the peer you want to build maybe the channel to, and then you open a channel with this person and you say how much funds you want put in there. If you put funds in there, those funds are on your side. So this is a little bit the thing you have to think about when it comes to payment channels. I can just receive what I what capacity I have on my side. So if I put in the beginning, maybe if I'm crazy, one complete Bitcoin into a channel, it's on my side. I can send this Bitcoin out a little bit little sets from this Bitcoin step by step over the Lightning network to other people. But the first Satoshi I can receive is just happening once I send the first Satoshi. So it's a little bit the concept there. I'm not going here into detail there, but something to wrap your mind a little bit around. But this is really, if you're managing your node yourself, you have to go into that kind of depth. I think for future, for people just using the Lightning wallet, there will be more simpler way to grasp this from just kind of an end user perspective. Here you get the full complexity of the Lightning network, so you can really optimize a lot, because the Raspiblitz is very optimized to be really an active routing node in the network. So this is really to be an active part in the middle of those networks and not just sitting at the end. So you have all the options here.
Are you connecting to, like, let's say there's another Raspiblitz?
Yeah.
There's also a Bitcoin core full node and an LND Lightning.
Yeah.
Are you connecting via the Bitcoin protocol as well as the Lightning protocol?
No. You use the Lightning protocol. So what you can see here, it's a little bit cut off. So sorry for that. It was just a screenshot thing. But you have a long node ID. So this long string is generated from your in the beginning, you set up your Lightning wallet, and you get a 24-word seed. It's not the same as you have on the Bitcoin, but it's very similar. So you get a word seed. And from this kind of private key that gets generated there's kind of a public key generated that's your node ID. And this is the kind of unique ID in the network. Then when you spin it up, it does like the Bitcoin network, but on another kind of protocol level, finds peers in the network. So you can connect to a peer especially that you want, and the address is always your node ID, and then an and then the kind of domain or IP address you are, and then the port Lightning is running on. So this is the kind of information you need if you really want to add a peer in the beginning. Once it's connected, you just need a node ID to do further kind of communication, because your node itself knows then where physically over the internet protocol the node is available. You will see this node IDs when you search. If you go into the search engine I mentioned in the beginning, you can see all this kind of addresses over there to where you really can connect the peers and then build the channels with.
But there's no, like, if you connect to another Lightning node, it's not default connecting to that Bitcoin core full node.
No.
Or vice versa.
In the end, the Bitcoin full node that is running on the device is just kind of an information service to you. It builds up its own kind of peers. of course, because it needs to be connected somehow to the network, but those peers doesn't need to be the same ones like the Lightning node. So it just takes its own peers, it follows the normal Bitcoin protocol, collects just the information about the blockchain, so that the Lightning client then can check, oh, is any funds are moving or something, like to see is a channel closing or something like that. So, so the Bitcoin service full node is really there for the full information service that is delivered to the LND node or the Lightning node in the end. Okay, so when you have channels open, then you're connected to the Lightning network. So what you then can start, of course, is creating these receivers, also to send funds over the network. So and to receive. The one concept you also have to grasp is, of course, that in Bitcoin you just set an address and you can send randomly, like spontaneously, like just funds to that address, and you make this transaction. And Lightning is working in, normally with creating invoices. So if I want to pay you, you create an invoice for me, and then I use this invoice to pay this invoice. So I need some information before I can send you money. So this is something to keep in mind. It's a little bit different than Bitcoin, but it's a little bit more like merchants are used to it. Like, they give you something, I want money from you, and they say, show it on your little device or something, and then you're kind of paying it, and this is a little bit more like merchant are used to it. And sometimes even easier for them, because sometimes if a merchant just receives spontaneous money, sometimes it gets crazy with the bookkeeping. Okay, so yeah, receive and sending, that's the kind of the base functions you would use. But of course, this gets more comfortable not doing it here on the main menu. This is just giving you the kind of base interaction with the LND CLI, with the daemon that is running now on the device. If you want to get more comfortable, of course, connecting it to the mobile wallet that you have in your pocket, for example, or another wallet that sits on your desktop or something like that, is much, much more comfortable. And also the web UI, which we see later on. Then there are some kind of service things you can do. You can export certain files you need. So if you want to connect another device, like a mobile phone or another wallet interface, or want to connect to the API that, of course, is now available for you here at your Raspiblitz to tinker on and to build on stuff. Then you need some files like the macaroon file or a TLS cert that gives you kind of permission and secures your connection to your Raspiblitz. So you can export it, get it in different ways. Of course, you can change the name. You can give your node a name, so that's always nice. You can even give your node a color. And then, of course, you can change the passwords. You can, and of course, in the end, you maybe want to cash out. That's always a good thing. You're putting stuff in there, so your funds, so there's real value there. So at one point, maybe you say, okay, I'm done. I just want to close all my channels. So maybe you have to wait a little bit until the funds get back into your on-chain wallet. And once the funds are back into your on-chain wallet, you then maybe want to send it to somewhere else, like your Trezor or something. So the cash out option is also, of course, available here if you really want to close it down. Then there are some service things, like you can see a little bit of detailed things. How much balances do I have in my channels or in my on-chain wallet? And of course, a little bit a small list of the of my channels to check on. It's just some little service things here. And of course, you can go to terminal. This main menu is just kind of an easy starting point for you. If you really want to explore really the Lightning yourself, the LND, for example, here on the Raspiblitz, you go to terminal and you can then there work with the CLI to really try out all the kind of features you get from your Lightning Network implementation, or want to talk to the Bitcoin daemon there. So the terminal, if you really want to go further, is your friend. Okay. Well, let's see. Yeah, I think we're good. The terminal is nice, but it's not for everybody. So of course, people are trying to provide better ways to interact with your full node. So what the Raspiblitz is making available to you, there's a service menu you pick in the main menu, and then you can activate special services. And one of the services is the RTL web interface. RTL is called Write the Lightning. The good thing is, for example, on the Lightning Hack Day in New York, I connected with the programming team that's behind the RTL, and as far as I heard, like when I signaled, okay, cool, we connected now, I think I will put this on the Raspiblitz, that was a good motivation for them to keep working on this. And nowadays, I really have to say, this project developed beautifully, and even the Nodal is using it in other kind of implementations. So you can see this interface even on other nodes nowadays. And it gives you, as you can see, like you activate it, and then you get a little URL. You just put it in your local browser. It's not available, you cannot see it from the outside, so it's just available in your local network. And you can see here a little bit more, maybe like you're used to it, better visualization, better interaction, and it's nice. It's a good dashboard and good operation board to really manage your node and optimize the routes or optimize the channels and so on. So just if you want to go deeper in there, hardly recommended. The only thing I would like to add is when you activate it, you install a lot of kind of web development stuff like serving, Node.js, and etc. That adds a lot of dependency to your device. That might be a security risk. I don't see it as crucial, but keep it in mind that at more and more service you activate or install on the machine, it broadens, or it makes the attack surface, of course, broader. So just keep it in mind. Comfort always comes most of the times with a little bit of compromise.
Is it the expectation you're only looking at that locally, though?
Sorry?
You're only looking at that Lightning locally, so it's...
Yeah, but you never know, like if there's some dependency that checks, oh, I'm serving in some Bitcoin system, and then I make a contact or something. Just to keep that in mind, because especially the web projects have a lot of dependencies, and there could be sometimes Bitcoin is a target, and if somebody sees, oh, my library is used here, so maybe make an update and can detect something, you never know. Just want to let you know, don't want to give people bad ideas, so, but it's an attack vector you have to keep in mind. Of course, we see the SSH interface. We saw the web interface with the RTL, and another interface that we had for a long time, but we're not using, is this little LCD screen, which is a touch screen. It was a feature that was in there in the beginning, but it was not time there in the past to utilize it. But thanks to some great contribution from Frankie, we now started in the latest version now to activate this touchscreen. And as you can see now here, this is the standard kind of screen, but we now have here some 4 extra buttons that we can now think a little bit how we will use them in the best kind of ways. Why do we choose these 4 buttons? It's like, if you look at this e-paper over there, an e-paper doesn't have touch, so buttons maybe are a way to keep thinking about. And if we have here 4 buttons, we can keep the interaction on the display set up very consistent. So the first approach here is, maybe we have to discuss now on this, it's kind of an experimental feature in the new version. Maybe I change here kind of the screens, and there could be now other status screens that people can get very creative on, what you maybe like to want to see, maybe even with some interaction, more interaction on there. And then you have some kind of action buttons over here, and on the status screen, the first action is of course a long requested feature, like I can turn off my Raspiblitz just through the touch screen. For example, if I cannot log in by SSH because something crazy happening, I don't know, but at least I can turn it down, can say, please shut down, so I can really just shut it down safely and not just unplug the power and then maybe something goes wrong there. Yeah, so this is very now coming with the Raspiblitz 1.3. Out at the moment is the 1.2, so this is something very new. There's a release candidate. You will hear a little bit later on, a little bit more. I talked about it's possible to connect mobile wallets to your Raspiblitz. So there's two classic ones, and there's even more now that are supported. On the Android side, there's the Django wallet, for example. And it acts, you have to, in the setup process, you have to say, no, I don't want your node, I want to use my own node. And then you have to transfer some information. So you scan a QR code with that is displayed on the LCD now. And this way you kind of connect them and exchange kind of the secrets you need and the securities you need to connect those. So in the end, those mobile wallets working like a remote control that you have on the road, like in my pocket, to my Raspiblitz at home. And a very beautiful one, of course, is the Zap wallet on iOS. So we can recommend it. It's a great UI, and it's getting better day by day. just again, you don't need a Raspiblitz to have a mobile Lightning wallet. So that somebody don't get the wrong picture here. Those wallets are possible that you connect to your own node, and in the past it was the best way to do it. But now we see more and more mobile wallets working like light clients with Neutrino and such technologies to provide you even that everybody can have very easily install a Lightning wallet and not needing to have such a full node over there. But I hope I made it clear why it's cool to have a full node running at home. Yeah, one caveat, or at least one challenge you have to master if you want to connect either your mobile wallet from the outside, or even also you want to make it very easy for other Lightning nodes to build to peer with you. So you need to be reachable. Your Raspiblitz need to be reachable to the outside world. But we have in the home setup, we regularly have a router that's hiding your devices behind the NUT. So, and also sometimes you really have the bad luck of working with an internet provider that really puts all your connections they are giving you behind kind of a provider run net. A net means that devices in your network don't get public IP addresses. They get kind of, this is how you get the local IP space. This is the common IP space you see normally on those devices, like with this 192.168 and so on. But those, you need an IP address to be reachable from the outside. So two challenges there. You need to be available through the IP address that your router has, because the router has a public IP address normally, and then you have to route this through to this device. So there's some forwarding going on. And then also with home DSL, there's often IP address changes, so you cannot just put a fixed IP in there. So you have to care about this, because this is always the IP address you tell to the outside, and those needs to be the latest one. It needs to be correct. So there are multiple solutions at the moment implemented. One is a little bit more the manual way. So for the changing public IP, you use a dynamic DNS solution. So your device always checks what's my latest public IP and tells it a second service, a dynamic DNS service. And once you at least have this dynamic DNS, so you get a little bit a domain address that always points to your latest public IP, you need to care about the port forwarding. So the port for the API the mobile wallet talks to, or the LND port, needs to route through the net, through your router to the Raspiblitz. So sometimes it's not for everybody easy to do this, and sometimes there's now the feature, the universal plug and play kind of feature, that you can even switch on under the services of the Raspiblitz that's using the universal plug and play features from Bitcoin Core and from LND. But on my router at home, I need to explicitly allow devices to use that feature. So I have to go into my router and do stuff there. So it's not the perfect solution, but it's mostly people can handle if they're a little bit tech savvy. So this is possible. Other way possible is to run your node behind Tor. The good thing is with Tor, it really finds a way out of the system, like to the internet, and it gives you to the Tor network, and it gives you the onion address. So this is a fixed address then you have, and wherever I plug my device in, as long as it has internet, it's reachable over that onion address. That's great, but the downside is, like normal devices, like your mobile phone, for example, does not come natively with Tor. So now your mobile wallet has a little bit of problem to understand this Tor address and connect to the service. So there are workarounds, but you can see it's maybe not the solution also for everybody. But at least to say why it's also interesting to think about Tor is Tor gives you an address that and you're kind of secured through the Tor network, so nobody knows exactly where you are. When you put your public IP address out there, what you normally do if you don't switch on Tor, you let everybody know under this IP address there's a Bitcoin Lightning Network node running, and people can even see what capacities your channels have, so they can see, oh, there's a big node running oh, this is an IP I can see. This is in my neighborhood because there are services where I can see where people are located, at least the areas, or even governments can of course get the name of the IP address and maybe, oh, if it's forbidden to run a bit Lightning node or something, where we never know what comes up in the future. So this can be, of course, there can be reasons to run your Bitcoin or your Raspiblitz behind the Tor network, and even running it from the beginning under the Tor network is a feature we are now working on for the new version.
The Tor is that also some ISP, if they see you're running Tor, that could just like point a finger at you, and there are like some countries who they're thinking about making Tor illegal, so that also like makes you stake out. And then if you use a VPN, well, then you have to use a VPN also on your router and also on your phone. So then other ports you have to open and other problems with a VPN and don't allow port forwarding. So I try to do this and I just don't see a solution, a real easy solution.
Yeah, it depends. What you think in Germany, for example, we never know what happens with Bitcoin, but I think like making every Tor user like illegal. So it's really something we always have to see where's the balance and what's the thing.
I don't see any good trade-offs, that's what I'm trying to say.
Yeah, but even protecting your IP out there, not being for other people, like for people that may be saying, okay, I know where this people live or where this person lives because it's just one house in that area or whatever, like, and then I will maybe break in there or something. So there can be risks that maybe it's a protection layer you may want to consider, but it doesn't make it easy on every kind of level. So all the time, maybe if you're more for comfort and want an easy way, you maybe stick to your public IP, but you don't make a big node, you just maybe experimenting. So something at least to think about. And now
they can narrow it down specifically. I'm assuming the state can do anything, but like a hacker can narrow the location down to a specific house, like a semi-detached house.
If anyone has a friend at the ISP, you know, I mean, there's like 5 big ISPs in the UK.
Okay.
If you don't know something like the ISP,
shared like dynamic IP, so it's not. It could be like behind a NAT, so you wouldn't necessarily know for sure. But.
Yeah, so we can go into detail later maybe on to see where exactly the risk factors are in a more private conversation. But in the end, you have to consider there is something to it, and you're displaying, you give public information out there about you in some kind of way. So consider this at least. A third way that it's already available since version 1.2 is using an SSH reverse tunneling over a public server. So this is also something you can use if you want a public IP address to be reachable from the outside and easily reachable for every kind of node or for every kind of IP device that doesn't have Tor. And for example, you're under behind the provider net, for example. So even whatever you do with your router, you will not get out of this net. So what you can do is, like, if you have another server out there, you can use this server as kind of a gateway. You can set up within a reverse tunnel. So this is something that is as a config script is in there. It's more like a special solution for a special case. But if you're in that solution, maybe look that way. Just one thing I want to mention, because this may be also interesting for the Raspiblitz, the Bitbox base, the one the Shift Crypto people are working on, at least they're thinking about a service where they run a server, and I think the server kind of setup will also be open source, so everybody may be able to set up a service like this. The idea is they give IP addresses to you as a service, but you don't connect them, but you connect to them through Tor. So the service they are running, they don't know who you are, but they give you a public IP address and tunnel the traffic through the service. And I think this could be very interesting to make such a service payable through Lightning. So somebody, because we have a node running here, there's funding on there maybe even channels are open. So I have funding, I can pay people. So if you give me an extra service I can use, this could be very interesting for everybody I have a server, I'm in a legal kind of way, so to not be a target or something, to set something like this up. Could be an interesting service to build on, and I'm interested to see what they are building, and maybe we adopt it in the future also for a Raspberry Pi setup. Okay.
Do you know how many public IP addresses they have? Are they going to charge for it?
No. It's really, I just heard it, we just talked in a podcast about the problem in general, and they say this is the solution they're considering to do. So so this was at least the information, more like a future planning. And I think I like the concept, and if they're not doing it, somebody else doing it, let me know. It would be very interesting to integrate. Another thing to consider is the initial blockchain download. So as we were saying, there's a Bitcoin full node running on there, and we have about 230, 40 gigabyte of blockchain data that you need to you need to load the old archive. But the loading would not be the problem. This thing, we have internet connections that are fast. Normally, the Raspiblitz, even the old one, has a valid connection to download. So 200 gigabyte takes a bit, but it will be there. A little bit the main problem is that you're in Bitcoin, you want to validate. Normally your Bitcoin full node is validating, checking the rules and everything when I download the blocks. And this is a processor intensive, or at least the hard drive needs to be very often called. And on the old Raspberry Pi that just had a USB 2 interface to the hard drive and a limited CPU and also a limited RAM. It was a process when you try to do it. You could try to sync yourself and validate yourself the blockchain with the Raspberry Pi, but it would take you like weeks with the old Raspberry Pi 3. And this was not practical for people to do, because you want to get finished in about a weekend, or even on a workshop that you're visiting and you have about 4 hours to work on. So there are multiple solutions to this. The Raspiblitz is offering this during setup or also in a repair situation. For workshops, it makes the most sense to give the people a hard drive with an already pre-synced blockchain on there. So they get kind of a already blockchain there. There's already a trust factor in a workshop, and it's more about the education. So you prepare a hard drive already with a blockchain pre-synced, and the Raspiblitz on setup detects this and just kind of keeps adding at this point where it was. Then there is, if you're in a home setup where you really start with blank kind of hardware, there is kind of the workaround of using a torrent download. It's not the best way to do, because if you want to build up a node for the future, the best way is really to check everything yourself. But for people that are just searching for a way to get going and want to learn about Lightning a little bit more than they want to learn about really validating themselves, this is at least a way to get going and to get started. So we will see later on that we get more and more away from those kind of workarounds in the future. But at the moment, the Raspberry Pi 3, at least that we're working in the past, is too slow at this point to provide something better. If you're a little bit more skilled, you can use the copy option, even with the Raspberry Pi 3. So the idea is like your laptop is a more powerful computer, better and can do the whole validating much faster. So you install a Bitcoin Core client and let it sync on your laptop, which is about kind of some days, 2-3 days. You have maybe to wait, depends a little bit. And then you have a validated blockchain on your laptop. So the only thing you now need to do is just copy it over to the Raspberry So this is a compromise how you can get started even with slow hardware and validate it, have it all validated yourself in your kind of own kind of space. Then there is the clone function. This is more for some people that they have already a Raspiblitz running, and you can take the hard drive and plug it into another one. Gets now even with USB 2, don't expect too quick of copy action, because this also takes a long time, but some people liked it, so I kept it in there. Good news with the Raspberry Pi 4 that it came out, and we'll talk a little bit more later or in some slides. We're now getting into the area where self-syncing and self-validation with a Raspberry Pi 4 and a good SSD that is connected gets into an area where it's kind of acceptable if you have a weekend time maybe to do it yourself. But we see now we get more and more, for the future, it looks like we can get more and more away from this kind of workarounds. But if you're working with old hardware that you have lying around, consider maybe those ways for the initial blockchain download. Another thing to take away, good power supply. Because the most kind of reported errors we had during our last kind of years, or a year, was that people were choosing a weak power supply, because the old Raspberry Pi was having just a micro USB, the same like you can use for your mobile phone, for example. So you have an old power supply lying around, you say, oh, it plugs in, works. And of course it starts to boot up, okay, it looks good from the beginning, but then the hard drive also needs power, and sometimes there are some peaks when a lot of working is going around. And then the power supply kind of craps out, and you get the hard drive is click, 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 and then you get really bad data writing, you get bad data corruption. And data corruption means you might really lose your LND data that it's on there, your channel state, and then kind of your funds are lost, and people, yeah, that's the part of the reckless part, that's not the fun part. So so the good thing is we found some power supplies for the old Raspberry Pis, for the FSPC, so you go with those big ones that really give you a good stable power supply. We have mostly the shopping lists on there that those are a good choice. And even the version 1.2 was adding a stress test. So in the beginning, if you're really starting the setup, it puts the CPU a little bit under stress test, and you can see a little bit the weak power supplies, the voltage will fall and will be detected and tell you, we do really want to use this supply, we don't recommend it, it looks like it will crap out in the end. So at least there are some measurements to get against this. Yeah, and the micro USB was really not a good connector for big kind of currents or you want to put through there. So the good news also is, thank you Raspberry Pi 4, they changed the power connector now to USB-C, and USB-C is from the beginning a little bit more built to deliver a stable and power and good current. So I hope there we will see less and less problems on this side now with the Raspberry Pi 4. So Raspberry Pi 4. Data corruption in general is something to keep in mind. And the good thing is maybe that in the past we were seeing now with people using bad hardware, we were seeing this so much that we now care about this, or at least this topic is on our mind, because the baddest thing is like you build something for a very good machine, a very good server, you don't see this case, but once it's happening, you really see, oh damn, now it's in production or whatever, like, and now this is happening, this is a bad thing. So the question is, what can you do to more and more protect the data that you have? First of all, of course, backups. Good thing is with the version 1.2, LND added a feature called static channel backups, because always the problem was you have the seed in the beginning, and you learned from your hardware wallet, oh, if I have a seed, I can recover and everything, even if I lost my hardware wallet, something like that. But this is just true, at least for the on-chain funds you have with LND. Like you can recover in some way, sometimes a little bit difficult, but you can recover your on-chain funds that are still on my LND wallet. But the stuff you have in your channels are really harder to protect, because in the end you need kind of the latest channel states to manage your funds. And if you lose if the data gets corrupted there in your channel database, you really lose the kind of control over your channel funds. So first of all, the static channel backup helps at least to have a little file every time you open a channel or close a channel. There's a file that updates, and the Raspiblitz now is copying all the time the latest version of this file to the SD card. So normally it's on the hard drive, but every time this file changes, it makes a copy to the SD card. So even if your hard drive craps out or something, you find this file on your SD card. But of course, what would be best? You have your seed maybe in a safe location, so maybe you want to put this static channel backup file also into a safe location that's maybe not on your Raspiblitz, but it's changing all the time, so you cannot just copy it once and put it away. So what is possible since version 1.2 is you can make an off-location backup. So there's a little script, and I can say every time when the file is changing, please copy it to my server over SSH or SCP file transfer. So you have to put some information about your server there. Or for the people that are more convenient, you can upload to your Dropbox. What is okay, because the file itself is encrypted by your private, also by your seed words. So it's okay to put it, as far as I at least heard. We can discuss this maybe in detail later on. But it's okay-ish to put it on a kind of public service like Dropbox. So, but in case your whole hardware kind of craps out or something like this, you now have your seed words, you have your static channel backup file, and together with those, you have very, very good chance to recover your funds in a worst case scenario. So, okay, at least we are just in the backup scenarios, we've seen some improvement. But of course, the good thing would be if we can handle data corruption on the file systems more reliable, or at least counter it with more measurements. Of course, we don't want to get super expensive. Of course, if you spend a lot of money, you can always improve. But what are the kind of cheap options to do it? One option is to do, and maybe not that good visible with the black tones over there, is maybe using a USB RAID. So it's two little small USB thumb drives. There are still some ports open. You put them in there, and then your LND data, at least, so the small important data, has a better kind of protection and in a kind of RAID setup over there. So it's something, at least for the future, that's still on the list to try out, and something at least I want to see if this can improve at least protecting your most important data on this device, on your home node. Another thing is, and I'm very open to feedback on you if you have any experience on this, is generally changing the file system of the hard drive from ext4 to Btrfs. Btrfs is a copy on write system, so what you can do there are doing snapshots. And the idea is more for the blockchain data. So because in the end, at the moment, if you get the data corruption in the blockchain, you really need to get the whole blockchain again. So like syncing it yourself or doing the torrent again or copying it over from your laptops is always a kind of pain. So the idea would be if we have a Btrfs, so where we can make every day maybe for 1 minute, so we shut down the Bitcoin full node and we make a snapshot of the latest state of the blockchain, and then we run into a data corruption file, we maybe can jump back to a snapshot. So we have to see. I'm very open for if anybody has comments on this, but this is at least something that's worthy to look into and would very good make it easy to recover a data corruption file on the time issue. So maybe later on. And if you have any other ideas to improve on data protection, please let us know. Let me know. Let us share this, because this is the kind of the phase we're into this project right now. In the beginning, it was important to make it easy to set it up. Now we were seeing a lot of people setting it up. This is kind of working. Now we are in a point where we want to make it more stable, so improving on the hardware, improving on the data protection, and then later on there are a lot of ideas what kind of other services you can add here or what other features you can add, but I think we need to get a little bit more stable and secure before we get more crazy with other cool features we can do. So,
can I ask a couple of questions?
Sure.
What's the actual problem once the database becomes corrupted? There's no way of like reversing that operation to get back to a state where it wasn't corrupted.
Yeah, that would be maybe possible with a snapshot kind of way, but normally you can really say if my hard drive or drive is writing something and gets corrupted right in the middle or something, there's a file not completely written and something is overwritten, it's a mess.
Yeah, if your HTLC is corrupted, you'd have to like do that handshake again, basically with your like counterparty node to get that.
That's for Lightning, right?
Right.
Like just let's just say the database is corrupted.
Yeah.
Bitcoin full node doing IoT.
Yeah.
Well, if it's just like the chain state that's corrupted, you can like re-index. But if like a block file is corrupted, then it's If a block file is corrupted, you need to get that new block file.
Yeah.
But why do you have to start from scratch? Surely you can just discard that corrupted block and just request that block.
Because your chain state, you're not storing like the historical chain state. You're only storing like the current like state of the UTXO, so you can't like play it backwards.
To that, build it up again from the beginning.
Yeah, exactly. That like the unwinding of it is not something that like it's a function that exists currently at least.
Yeah, at least if you know any kind of feature that could be turned on in a Bitcoin Core kind of setup, let me know, because this is also something, sure, if we can find any kind of way, but at least all the experience we made so far was there is no kind of easy way or fast way in a data corruption file to protect it. So the idea was, we were thinking about is like, let's look at the file system in general, and maybe we can find a way there to have a kind of way to switch back a bit. So.
And very quickly on Lightning.
No, I just want to comment that since we are testing the power supply and we put the better ones on the shopping list, it's very rarely seen that people get, the
Yeah.
HD getting corrected.
It's getting much better. So really, before 1.2, we had a lot of kind of this errors because you have really this very cheap system there and cheap power supply and the hard drive is very demanding on the power side. So this was a kind of often thing. But now really with the stress test and really better shopping lists, recommending really this power supply seems better. But from this learning that this will happen at one point, maybe the power cuts out at your home or something, you want to be prepared for that, and it should not be kind of a complete another weekend project to get it back on running. So
then on the Lightning front, like with LND or any of the major Lightning implementations, you can't currently request that your peer does a cooperative close. So like the problem is you don't know what the latest state of your channel is. And so ideally, if your peer is honest, you want the peer to enact the cooperative close, and as long as it's a future state in comparison to any states you're aware of, you just sign that off. But you can't currently do that with LND, can you?
Now the static channel backup helps you a lot to keep an overview of what kind of channels I had open at all, so they have this information somewhere. And gives you some information in there to agree on cooperative closing.
I think in the bold spec there's some optional parameter where if like you go offline and you come back and you're not sure where you were, you can ask them or something like that. But,
That's what the static channel backup does. When you restore from that, you basically ask the peers to force close for you.
Yeah, or cooperative close. Yeah, it depends. Yeah.
That's what.
Yeah.
But it doesn't. It always ends up if you restore from an SCB.
It's
force closing everything.
Yeah, it's always force closing. Yeah.
Except the ones which are not backed up. It's an outdated SCB, but still back to that.
So ideally, you want to try that cooperative close first. You want your peer to enact that cooperative close, unless you're unhappy with the close that it's enacting. In which case, then you'd want to do the force close.
Yeah, absolutely. But we are talking about a status where you lost your information on your...
where some, and then normally the problem is there's some database file, and if there's in the middle something going wrong, it's hard to reconstruct it. At least there's no measurement in the implementations are not written that way to work with corrupted data. So if there's something corrupted, they cannot use, you cannot open this little database where your stuff is in, and from there it gets tricky. So it's more easy to have some backup way, or at least to build a system from the beginning in some kind of other recovery ways. So.
As a side note, I was told never to use like rsync and stuff with LND. It's not reliable.
No. The idea, that was the idea you had in the beginning. I just need to kind of, there's this one directory, there's all my databases and all my latest data in there. Why I'm not just kind of constantly backupping this one? This can be you can get into in a middle state, and then you have then you use those a little bit too old backup, maybe just a too old backup. But their channel state has already changed, and then you publish an old state, and with the current Lightning implementation, with the penalty when you cheat, and cheating is posting an old state, then you maybe lose all the funds in the channel, and this is all messy. So the static channel backup gave us the first kind of way to have a more cleaner way for backup, and really it's for the worst case kind of situations. So at least good to have it there. Saves a lot of people some funds.
The ongoing active states you can only back up if you shut down the node.
Yeah.
And then you can copy it off.
Yeah.
But then you cannot restart it anymore because it gets outdated at the moment it started.
Yeah, there's a feature in the Raspiblitz where you can make kind of a backup of your LND data, but it requires you to shut down LND, make the backup, and then this is more for cases when you want to move your state to another Raspiblitz and run it then there, or move it to your desktop and then use it with another app or something like that. So you should not make a backup as long as the moment you turn on your LND again, you should not use this whole kind of complete backup file anymore. It's more like you're moving or during update times or something as a measurement, security management. Okay, so let's get back to the good news. We have the Raspberry Pi 4. This came as a surprise. I personally was not expecting a Raspberry Pi update this year. And as I was saying before, you saw a lot of points where we had a little bit problems with the old hardware, or at least had to do workarounds. In generally, the Raspberry Pi 4 has a USB 3 interface, at least 2 ports but that's good. This gives you a lot of enhancement on the reading and writing speed with the hard drive. And now, because a lot of people asking, why are you not using SSDs instead of a mechanical hard drive? It was in the past, the Raspberry Pi was so slow on the USB interface that it wouldn't make sense to use a more expensive hard drive in the end. So now we have the USB 3 and we can utilize even good SSD speeds. So it would make sense in the future now to at least think about a package somewhere that recommends using even SSD to have the speed up there. It has a faster CPU, so this adds also into the idea of doing the self-validation and self-syncing. So the old CPU was fast enough to keep up with the blockchain, to validate everything in a kind of running state. But if you have something to do, like validating a complete blockchain or something, the old CPU was too slow, or at least could be faster. Now we have a faster CPU, that's great. We see better power supply loaded here now. This is a change from the micro USB to USB-C, so really good thing. We saw a lot of problems we had in the past were connected to power supply. USB-C is a better connector, possible to put more stable power through there. So that's a good move, at least very good update there. And the nice thing is that the old Raspberry Pi had 1 GB RAM. That was limiting some ideas for the future to put something extra on there, like Electrum server or something like that. Always was kind of do we have enough RAM? Now with the Raspberry Pi 4, it comes in different flavors. I think 3 flavors. One is 1 GB, 2 GB, and 4 GB. So if you aim to do really more feature stuff in the future with your Raspberry Blitz, then consider really a Raspberry Pi 4 with a maybe 2 or even 4 GB RAM. Yeah, it's a great update. We're testing it at the moment. There's even already a Raspiblitz version available, the version 1.3 release candidate 1, that is compatible with the Raspberry Pi 4, because there's an update in the base OS, like Raspbian Ambassador is needed, so that you to run there. But the good thing is the new version is also running on the old Raspberry Pi 3s, and so will have 2 kind of downloads there. So this is kind of a good thing. Yeah, what we do is we're searching for a new case because of this update features. Something changed, and there are not good cases. At least those cases where you can put an LCD screen on there and it fits well and it does everything good with temperature and all this stuff. So there's something we're still searching for. So this will hopefully, with the release candidate, we have some time still to find a solution there for the shopping lists in the future. And the shopping list, I think, will go now from one recommendation maybe to kind of separate recommendations for a cheap setup, where you can even use the old Raspberry Pi 3. But then we maybe have an economic kind of best kind of bang for the buck kind of mix. Where you get most power for the best money, and then there's maybe a luxury kind of setup when you really say, I want to play a lot with this thing and max this thing out.
Regarding the casing, I try to use it with a case, and it gets hot.
Yeah.
Wouldn't it be actually better to run it without a case, because I found it's just better like that? Wouldn't be that a recommendation actually?
I have the test setup with the Raspberry Pi 4 over here, and but what you have to really take care about is at the top there's a lot of kind of connectors. So at least make sure, if you have the aluminum casing or something, at least critical isolation at least at one level. So having those connectors all kind of laying around, or can end up in a bad way. So casing makes sense at one point, but if you like the optics and the style and you can take care about it, why not? So one thing is about, and this it's a cooling thing. The Raspberry Pi, the old Raspiblitz had, and in the end, had a very big, we recommended at least a casing that was kind of almost just a passive cooling element. What kept it about was reducing the heat about 10 degrees Celsius. What puts the old Raspberry Pi in a good kind of way to operate, because the problem if it gets too hot, it kind of reduces the CPU speed. So, and then you lose, and everything takes more and more time, so that's not a good experience. So with this passive cooling in the last version was okay. But now with the Raspberry Pi 4, we see a little bit of this kind of thing. So you can see, like, here's the scale. So you can see the red thing is about getting up to 80 degree. So the CPU, as you can see, can get very, very hot when it gets a little bit into stress. And this is really temperatures we haven't seen before on the Raspberry Pi 3. And so the solution is to use an active cooling, and of course there's now the thing, we need the active cooling that still works when the LCD is on top. So what I have here, and you can show it to you later if you want to take a look, is this shim fan. So you kind of stick it stick it on the GPIO pins and the LCD on top, so it's kind of in the middle. The fan is directly over the CPU, and from these tests here and from the practical tests I did so far, it really looks good. It puts it here, as you can see, like in a 30, 40, 45 kind of way in a normal regular way, and even under more stress, it really keeps it below 50 kind of way degrees Celsius. So that's a good operating level, and I think this fan solution is something to work with. Running it without a cooling solution, really be careful. It gets hot. 80 degrees is no fun anymore. So if you really touch it, or maybe even if you have cheap casing, maybe melt. So get ready for problems if you don't care about cooling there. Okay, so some stuff to mention. There's not just the Raspberry Pi can be used. There's also, thanks to somebody even here, Open Arms. Thanks for contributing so much on that topic. There's a folder in the GitHub, alternative platforms. So in the end, there's a lot of shell scripts. There's a lot of stuff that's available that could also run on other single board computers for other processor architectures. So there are some little switches there and some scripts, but in the end, it's possible to do. We see here the prototypes, and maybe later on you can even share a little bit like your experience, what you can recommend to use or not. So at least you can see there's a possibility to even experiment with other single board computers if you just don't like the Raspberry Pi. The only thing from my side is to add, or at least that's my goal, is to keep it always focused on the Raspberry Pi as kind of the entry-level computer. But with the Raspberry Pi 4, we're seeing now a lot of improvements, so even on power and all the stuff, so that's great. Okay, so I already talked about the Raspberry Pi next release, the 1.3. I think the final release, so the release candidate is out. I think the final release we'll see about mid of this month, maybe some weeks later, we have to see, but roundabout. And yeah, the Raspberry Pi 4 support, there will be an LND 0.7 will be on there, latest RTL kind of version. The question is still, I'm not totally decided there is, at the moment it comes with the old Bitcoin Bitcoin Core 0.17.1. Maybe there's the update to the latest one. There was some mentions that there could be, but I don't know, we can discuss this later, we have to see. Yeah, the feature that's new, a lot of bug fixes of course, but a feature that's new, you can maybe, during the setup, you can say I want to have it behind Tor from the beginning, because just to let you know, if you start, you normally have it with your public IP, and even if you then turn on Tor, you once let the network know, so you maybe make no sense to turn on Tor in the past when somebody already kind of wrecked it and put it into some kind of database that you're running this node, and so this makes sense to maybe have it switched on from the beginning if you're privacy aware in that direction. Then the blockchain, in the past there was always the need to turn on the indexing, so the old LND needed this, the newer ones now is not needed anymore. So this makes it more easy to use your self-validated blockchain from the laptop, because you don't need to change anything, you just install the Bitcoin Core there, validate the blockchain, and then you use that blockchain to copy over. So if you still that road, it's much more easier. With this change, new torrent files available, there's a better repair menu, and there's experimental touchscreen support. Just in case, if you now have an old Raspiblitz running and you think, oh, how do I upgrade? A software upgrade, hardware upgrade, how do I do this? So in the end, the updating in the Raspiblitz is just working by replacing the SD card image. So the best way is even buy a new SD card, a second SD card, put the newest image on there, like you did before with the old one, and then you power down the Raspberry Pi, you exchange the SD card, and then it kind of goes into a recover and update mode, and you just have to reset up the base password A again, and then it should be back and running the latest software with a fresh system. I know somebody don't like this update process, but I prefer it because it prevents decentralization. Such kind of updates can be somebody says, oh, I make this kind of flavor of Raspiblitz, I make this flavor of Raspiblitz, and so you can really very easily kind of exchange stuff, and you don't have some central server. And also with the SD card change, you exchange the complete software stack. So this is a good thing because the software stack is tested, and so you just make this one switch, like a new Raspbian base image, a new Bitcoin Core, a new LND, and you get this is kind of fixed. The only takeaway here is if you experiment with it and build own scripts during an update, make sure to back up your scripts, because then you get this fresh thing there, and if you even overwrite your SD card, you maybe lose it. So take care on that one. And how do I update from my hardware? Just exchange the hardware during the setup, so during the update. So if you power it down, you make this new SD card, you exchange the Raspberry Pi 3 against the Raspberry Pi 4, and you just power it on with the new SD card, and you should be good, because all your data is on the hard drive. So this is the stuff that's then still going on. If you want to update the hard drive, there's another process, but I don't want to get into that now. Yeah. And some future stuff, but maybe just to let you know, at the moment it's very, very based with working with shell scripts. There's maybe the idea to change to something like a Blitz daemon that's taking a little bit more care about background processes, or having a little bit like a node from LND and from Bitcoin, so that you maybe even have a Blitz daemon, so that it takes care about all the stuff the other daemons don't take care about. That's maybe written in Go, so we're thinking about that. Maybe working on the chaos communication camp coming up there. We will sit a little bit together and see where we go in there. But if anybody has input there, just let me know. And to the end, so my last slide. So what is the kind of merchant setup? We always talk like you use this kind of as the Raspiblitz for having it at home for you personally, but think maybe of a merchant and that wants to use Lightning now. There's a lazy merchant, or maybe the merchant looking for most comfort. They maybe use something like the Strike service by Func. And as you can see now, the idea is a little bit small Lightning payments coming in. Then you have some Bitcoin balance kind of your side, and at one point, you want this Bitcoin maybe in a more safe place, like your hardware wallet, and you have this transfer. But here comes the point: you don't run your own Lightning node, you don't run your own full node. So this is more like a lazy solution where you're trusting a third party to a certain degree. So it's okay to start with. I don't want to, but maybe if you want to go to a better kind of solution, you can use the Raspiblitz, and this is the kind of setup we're thinking about now to get running in room 77 in Berlin as an experiment. And here comes the point, like when I was asking, oh, let's just put a Raspiblitz there and connect the mobile wallet. And, oh, I don't want to have this in my bar, the Raspiblitz, because it's a hot wallet, somebody comes, I don't know. So the idea is you put your Raspiblitz in a safe location, off location, like at home or in your office where it's kind of locked up or something. And in your bar, you have just an on-location device that can just create invoices. So you can use the macaroon service, so you just put an invoice macaroon, so it's a special file that just allows this device to create invoices, and everything that's sent to here ends up in your Raspiblitz. But this device can be a very cheap device, or even self-built, and Ben will tell you a little bit about this little device, the flux capacitor, where you can really easy punch stuff in. So it's like a very cheap device that you can put behind your bar, and if somebody steals this, nothing gets lost, because it just can read. So that's the way.
How is the solution different to the BTC Pay server then?
The BTC Pay server at least is more built that it runs on a server, and you have to have a device there that's in talking to the server. It's also a setup you can do. And then I'm just not saying that.
I was just curious, what is the difference in between them, like certain trade-offs?
Yeah, you don't have to put kind of server. So of course you could install the BTC Pay server here, and then it just makes kind of calls. There's always a solution, sure. But the idea was make it with at least extra install over here, and just keep it really on a base L&D level to work with.
And also BTP server is like a Docker-based service, so it's much more pre-packaged. Here you validate and build yourself.
Yeah, this is kind of the very simple way to use in this use case. BTP server is much more powerful that you use for your online web store and something. If you're just searching for a small bar solution, I think it's a way to look at it this way. But in the end, it's really not for every merchant. It's for the technical interested merchant. So, and in the end, then you can always kind of, if you have too much kind of here on your Raspiblitz and your hot wallet, you maybe want to then to put stuff into your hardware wallet. And maybe with a service like Loop Out in the future, it even can make sense to really put a lot of funds from here into the hardware wallet and free up inbound capacity so that you can receive again Lightning payments. Okay, so almost done. So when is the next Lightning Hack Day? A lot of people ask me this question, and what I can say, we will not have a Hack Day. We will have even a Lightning conference that now we are organizing from the Fulmo team. It will be 19th, 20th October in Berlin. So we will kind of carry on the Hack Day spirits there, but it will be a little bit bigger. It's like a conference format, like everybody from every kind of Lightning implementation will be around. So mark the date. It will be early bird, will roundabout be, roundabout is not the final price I heard now, about 80 euros. So this is kind of the entry level, not the €5 we had like for the Hack Days, but I think it's still a good deal if you get an early bird ticket. Would be lovely to see you all, so it would be great. And I hope we will have those Raspiblitz drinks over there. I just somebody sent me this picture, so it's a really brewery that having a drink called that way. So I think it's a must now to have this drink also at the conference. So would like to invite everybody joining there. So that's it from my side. So.
This onto here. So I went to the first Lightning Hack Day, and I wasn't sure where I could contribute because I'm not really a developer or anything. I used to be a teacher, but I also at one point taught electronics. And I saw a lot of people with nodes and trying to put nodes into things so they could accept Bitcoin over Lightning. And then I thought, well, that seemed a little bit silly because there's a security risk if you put a node inside a vending machine or a sweep machine or something, in that it's a hot wallet, like Christian said. You want your node to be somewhere secure. So I thought, I'd had some experience playing with microcontrollers and sort of Arduino hobbyist projects, and I thought, well, you can easily, with a microcontroller, use that as a slave device, which then communicates with your node, which is the master device, which seemed to make sense to me. Let me see if this is working. I might have to upload that again. So I started playing around. If I share my screen, as I said, you'll have to give me a moment because we're sort of sharing a laptop, so it's
yeah, I forgot my adapter, so it's my fault.
Blame Christian. Right, let me see if this works. Yeah, let's keep these changes. There we go. Yeah, I'll be alright showing that. And 1 second. I'm trying to dox myself here. So I started playing around with the microcontrollers and then trying to get them to interact with an L&D node, for example. So a little project which we've made is the idea of if you have a screen on your Blitz, then there's more libraries and more things you need to include, and then that opens up more attack vectors. And also, one of the benefits of having a screen is you can check on the stats of your node, but that kind of means that your Blitz is going to be somewhere, your node is going to be somewhere very public. So if you could have your node somewhere secure and then just have a tiny little device which is able to communicate to the node and then display that information, that makes a lot of sense. So, and I also knew that they were quite simple to work with. So this is the base microcontroller, I don't know if you can see it there, which I use, and it's called an ESP32. This is an ESP32, and this is actually a dev board. That's why it's got these nice big GPIOs to work with, and it's made for like hobbyists and things. So it's it's not particularly hard to work with, and it's incredibly cheap. So these are like $5 each to buy, and you can actually as well, if you have some projects where you need something a little bit more bespoke and something where you're building this ESP32 into a device, you can actually buy just the microcontroller itself, and then through a module like this, you can pop that in, and then you can flash it with code and get it to do stuff. And just to buy this microcontroller here, you can get these for about $1. So the microcontroller itself is capable of running a web server, can do Bluetooth, can obviously send commands over Wi-Fi, and as I said, it's got a whole bunch of GPIOs where you can do different types of communication protocols, such as SPI, which means we can communicate out to little screens like this little e-paper screen, for example. So I started off and I thought, well, I wanted to kind of educate people, because obviously the thing I like about the Blitz and the thing I like about the hack days is you're giving people autonomy, you're teaching them how to handle this hardware themselves rather than trusting companies to do it for them. And that's pretty much what I think Bitcoin is a lot of Bitcoin is about. So I wanted to try and give some of that autonomy and try and encourage people to learn. So I made a whole bunch of YouTube tutorials which are on World Crypto Network if you want to check those out. There's a playlist on there with all my tutorials on. And the first tutorial I did was I just got the ESP32 and I made what I called a fake hardware wallet, but so the idea being that if somebody breaks in and they're about to steal your stash, if you power up this device, it will send a message to a Telegram group with all your mates on saying, help, I'm under attack, can you please call the police, blah, blah, blah. So you could, if you wanted to, you could wrap it up in a little case, make it look like a hardware wallet. But then you can also just add a button to it and a battery, and then when you flick the button on, it sends that message every 30 seconds or something on that Telegram group. Or you could put it inside a safe, so it's triggered when the safe's open the wrong way or something. So that was quite a fun little project, which some people may find useful. And then from there, I then attached the e-paper screen through SPI. And all these components are incredibly cheap. So the e-paper screen, for example, the one I use is about $10, and the ESP32 is another $5. So it's only $15. And this one's just a little price checker. Now, one of the great things about the ESP32 is it has functionality like a deep sleep mode. So it can wake up, perform a function, and then go into deep sleep where it keeps some of the controller awake, but only the bare minimum. And then it uses an incredibly low amount of power, like 0.04 milliamps an hour. So off a battery, you can have a device like this last, a year, for example. And then from there, I was able to connect to, as Christian said before, you have these sort of, lazy surfaces like Async Strike, or the one I've been using is OpenNode, where they have an API where you can make an account very easily, and then you can get an API key for generating invoices, and you can get this little microcontroller to communicate to their API, ask for an invoice, bring the invoice back, and then display the invoice. Which obviously, as we've seen here, because we're able to do post and get requests to the L&D node, you can easily get it to do the same thing to your L&D node. All you need is the macaroon, it works kind of like an API key, and the TLS certificate just to get access to the L&D node. So with these projects, there's like the lazy way of doing it, and then kind of the tinfoil hat, run your own node kind of way. But I think it is important to think of, say, my guy who got a coffee shop down the road, he wants to accept Bitcoin on Lightning, but he's not comfortable being able to set up and run his own Lightning full node. For him, quite a good setup would be to have like a dedicated little device in which he can generate a Lightning invoice, and then have those Lightning payments concatenate together and output to a hardware wallet. Or with OpenNode, it can even output to a bank account, which I don't know why you'd want to do that, but you could technically do that. It'd be quite nice to, what I'll try and do is demo this little point-of-sale device. So if I turn back on my camera, where are we? Here we go. So what have we got? We've got the ESP32. We've got a $10 e-paper display here, and then we've got a 50p keypad. So like way under $20. And then in here, if I input an amount in Satoshis, so say 50 or 5,000 Satoshis, and then if I hit the little hashtag on there, let me try again, hit that. It's always the way, isn't it, when you do a demo? No, why? Oh no, wait, it was the actual, I think it was the e-paper, the e-paper, the little wires fell out. Because obviously, trying to keep this as simple as possible, I try and use jump cables as opposed to soldering the wires, because not so many people are so handy with these soldering irons. But by doing that, sometimes these little jump cables fall out. So for a better effect, you would, oh God, for a better effect, you would obviously solder them. Look at that. So this is working really well before. There we are. Let me pop it out and pop it in again. Okay. So as Christian said, room 77, for example, they want to be able to accept Lightning payments for the bar, and they don't want to have a like a phone which they keep at the bar, and they want like a sort of dumb device which is durable and has large battery power. So using those same communication protocols like SPI and I2C, I got like a nice chunky keypad and a nice little backlit display here, and that just basically does the exact same thing as this, and it's cheap. And then by doing that, oh goodness me, oh look at that, that's why the wire's falling out of there. Right, one more go. Let me plug that back in. Come on now. Maybe I've killed my e-paper by being too rough with it. No, okay. So if I just carry on and just ignore the actual demo bit. So what else have I done from there? I've experimented. So Espressif, who make the ESP32, they've released an official mesh development framework. So I've been experimenting building a mesh in which you can broadcast Bitcoin transaction data out onto, and then also have kind of a unicast path where you can send transaction data through. As I said, this little, just the controller itself, you can buy for about $1. And then you can retrofit into, I don't know, a power source such as a light bulb or USB cable or a keyboard or something. And the ESP32s, when you build the mesh, they have a 200-meter radius, so they can communicate with each other, and they can communicate at speeds of, say, up to 10 megabytes per second. So other experiments in the mesh network area at the moment, kind of revolving around GoTenna, they're very limited on bandwidth. But with this project, the actual motivation behind the project was I live in a small village and I wanted to blanket my village in Bitcoin transaction data, which is a freely accessible service. The idea being you could have a Blockstream satellite pulling data down and then broadcasting that data out to the whole mesh network. People can connect to it and they can get the data for free. So if the internet were to go down, then lots of people can access that data. I figured out to blanket my whole village in Bitcoin data using these little ESP32s, including the retrofitting, would probably cost me about £100. And then ultimately to be able to put them maybe in, I don't know, street lights or something, or some sort of power source, because they draw very little power, that would be like absolutely ideal. So far in my experimentation, I built the mesh network, so I've got videos for this. I built the mesh network up, and then experimented just getting them to work, and then I did like an experiment where I sort of set them 200 meters apart, and was able to like turn all the little LEDs on, and then turn like. So one of the best things with the mesh network is you can target specific ESP32s, so I can like turn that ESP32's LED on. And then the next stage, which I haven't yet released, is sending out that broadcast the transaction data as a broadcast. So that's pretty cool. So that's another little project using these devices. And then also, I mean, there's so many little modules you can add to these things. One of the modules I got and I started playing around with was an Nfc Reader. And using an Nfc Reader, you can, I mean, it's a bit hacky at the moment because you could load a macaroon, an admin macaroon, onto an NFC card, and then you can input an amount on the device, and then hit to pay. The NFC reader here waits for the information. You put the card against it, it takes the macaroon, and then it makes the transaction. However, in the future, obviously, in LND, we're going to have custom macaroons, and you could be in a scenario where you have a custom macaroon which you can spend, £100 a day, and you can only make, £30 transactions, and then you can add a caveat. So each transaction each macaroon which it generates, you can only use for say 10 seconds. And then using this sort of setup, you're able to simulate tap and pay, which we have here, using bank cards. And it's an absolute pleasure to like feel a Lightning transaction happen just by tapping a card onto something. It's a real frictionless way of paying. So it's kind of proof of concept, but it was pretty fun. When I was at San Francisco Bitcoin conference, so I went to the San Francisco Bitcoin conference to add some little modules using these this hardware. So you could pay for an arcade machine credit using Lightning. So I had a little OLED display, which was incredibly cheap. I had an ESP32. That was requesting an invoice from OpenNode, displaying it on the QR. You could, on the OLED. You could go up to it, pay it, and then it would register a credit on the arcade machine, which a lot of people seem to enjoy. So from there, I met Stepan Snigarov, and we worked together on a hardware wallet solution. Well, he did most of the work, to be honest, but I think I kind of spurred him along and got him excited about it. So a hardware wallet using an ESP32 and an e-paper display, so a $15 hardware wallet. Currently at the moment, it's a watch-only hardware wallet. So you give it your master public key, and then from that master public key, it can generate new addresses. But the great thing about it is, have I still got a daddy? Yeah, I think it's pointless me trying to demo that. I think one of the wires is like broken or something. One of the best things about it is that so if you've got your Trezor at home and you want to generate a new address and you want to have like a watch-only wallet where you can use a master public key to generate new addresses, you can put it on your phone, but then, or you can put it on your laptop, but you can put it on this dedicated device, and you press a pin, it refreshes and it generates a new address. You can use that to receive funds, and your Trezor can be nice and safe and secure, and it means that you don't have to get your Trezor out. So it's kind of a fun, hacky experiment, but I've been working with Stepan, and then this will become like a full hardware wallet. Yesterday in the BitDevs, there was a lot of discussion around hardware wallets, and I think that if you give people the ability to build their own hardware wallets, there'll be all this interesting innovation, and people will experiment with ideas. Maybe adding a camera, which you could use to take photos and hash through to get random generation of numbers, or other sort of little modules and things you could add onto it. And it will teach people about how hardware wallets work, but I think that could help. Having like free and open source and DIY hardware tinkering could inform hardware wallets on the ways in which they should go, the proprietary hardware wallets. So I'm quite excited about that little project as well. Let's give it one more try and see if we can get this bad boy to fire up. It's the wires, it's so annoying. What I'll do is I'll change the wires over and I can show you all later it working.
Should have spent another couple of pounds on the wires.
Do you know, this is my problem, because I'm obsessed by cheap stuff. So I bought the cheapest jump cables I could possibly find on AliExpress, and this is part of my problem.
The best £2 you ever spent.
I know, it's ridiculous. Well, it's pence more. Right, so let's have a look. It looks like it's working now. Let's have a little look. Right, so you'll have to, if I turn that round that way, maybe you can see it. So it just says enter an amount and then press hash. So I'm going to enter an amount, and then I'm going to press hash, processing. It goes and fetches an invoice, and then it turns it into a QR code, and then it just sticks the QR code on the screen. And just to show you that it's not like a blag and complete lie, I'll actually pay the QR code now. It was funny actually, because I demoed the sweet machine I made at the second Lightning Hack Day, and I hadn't quite finished it, but I was almost there. So I had like a button, and then I pretended to pay the QR code, and I sort of pressed the button, and the sweets came out, which was brilliant. Everyone, woo! And I was like, yeah. There we are. So here we are. So we've got a Lightning wallet, and then I scan my QR code.
I don't think we can see the screen. No,
Oh, okay, sorry. I daren't move the flipping the e-paper, but I'm going to have to move the e-paper. So if I put that there and then move this up to here, would help if I move my finger out of the way. I don't know if it wasn't so shaky. There we are. So hold on, my phone's gone. So there we are. So there's the invoices come up here. Okay, we're going to get there. I hit pay, and then hopefully it'll pay. Once it's paid, the device should, unless I've knocked the wires out from the e-paper display again, which I think I probably have, it will then refresh, and then it'll be ready for the next person to come along and pay, which I think I have by move. Oh, there we are, yeah. There we are. It has actually got as well in the GitHub for the project. It has also got an additional LED you can add, so it gives you some sort of feedback. It like lights up when you make the payment. But as you can see, it's quick. And for somewhere like Room 77, this is a nice bulky plastic ABS case. It's got a huge battery inside of it, which will last forever. You can expect just punch in amounts, take Lightning transactions. He probably doesn't have to worry about charging it hardly ever, but when he does, you can just plug it in and charge it, and then leave the device on premises. And as Christian said, have his Lightning node somewhere really secure, which is great. Other things which I'm quite interested in, like you said, when you add RTL, you have an issue of adding more vulnerabilities because you're adding maybe Node.js in there. With these little devices, with this ESP32, you can run a web server and you can deliver web pages. So there's no reason why this little device, just this device alone, couldn't make API requests to the LND node and then on the network display an RTL style GUI for people to interact with, and then you haven't got the issue then of installing that stuff on your node. Your node's kind of air-gapped from it. So there's plenty of projects to make with this stuff, and there's lots of projects which are coming out of more projects. So I'm very much into trying to get other people to experiment and build on these little things. They're super cheap, so there's no real excuse, financially. And particularly when you start getting them to engage with an LND node, you can do all sorts of interesting stuff. Another project would just be to simulate the screen on here, and the touch screen in particular, and then run a separate touch screen which is powered off the ESP32. So Espressive, the company which make the chip, they've released official support for Little VCL, which is a really nice GUI library where you can have like touch functionality and things. And you can plug in a touchscreen LCD to this and it'll work like that, except you've air-gapped everything. And maybe it creates a little bit less heat for your device as well. So that's pretty much it. I have to give a lot of credit to Christian, because in those Lightning Hack days, they were incredibly encouraging in just getting people to get involved and build things. And there's a whole bunch of people who came out of those hack days who've built interesting things. So my friend George in New York at the New York Hack Day, he's the first one who did the arcade machine, which I've then sort of used the concept of in San Francisco. And then, like Rene Pickard, he got really excited about the whole thing. And they did a real service to the community by building up all that excitement and momentum, and there's all these little projects spinning off it. And then hopefully as well, so some of my projects, when I did the Sweet Machine tutorial, within about 12 hours or 24 hours, within 12 or 24 hours, a very short period of time on Twitter, someone had got a pinball machine and then had retrofitted the e-paper display onto the pinball machine and was able to pay credits for their game on the pinball. So it's cool. You've got these very cheap devices. You can turn them into slave devices, get them to accept Lightning, get them to generate Lightning invoices and check to see if Lightning invoices have been paid, interact with LND nodes, and they're great. And everyone please do experiment with them. And if anyone wants to help on the Bitcoin Mesh project, then that would be great, because I think I've bitten off more than I can chew. And that's about it. Any questions? Thank you. Good.
What have been your biggest challenges, you would say generally?
I'm an idiot, so developing is very hard for me, and I generally just throw stuff up, like throwing mud at a wall until it sticks. So it's taken me a long time, because I wasn't a developer, so just very basic concepts for me. I've done some sort of hacky development in the past, but just very basic. I found some very basic concepts, big hurdles. So I hope that in my tutorial series that I kind of help people pass that learning curve, because it's really not hard. Have I got here, for example, let me show you the, can I show you, I can show you this. So this is the watch-only wallet. There's a public address there, but there's no funds on there, so it's all right. And it's only a few lines of code. It's not particularly complicated. This is Stepan's library he's written, which is specifically for Bitcoin, which is fantastic. But Arduino, they have a whole, because it's such a big community in the Arduino maker scene, they've got a whole bunch of libraries for developing on these things. So there's a library for doing the QR code, for example. If I get up another project, this is the, there we are. Doxed. I'll have to delete that API key right there. This is the point of sale terminal, and it's there's like a nice library for the e-paper. There's a nice library for working through the JSON, which comes back from OpenNode or from the LND node. There's a nice library for the keypad. So it's very modular and easy to build on. And any device you find, you'll be able to find like a YouTube tutorial or multiple YouTube tutorials on how to add that to something like an ESP32. So there is a lot of community support out there. But no, for me, it was just when I went to the Lightning Hack Day, I knew these things were possible, but then I was like, right, I got to learn a lot of stuff in order to make those things possible. So, but now I'm sort of getting there. I'm really excited. I'm not running out of ideas. The more I work on this stuff, the more ideas I have, and then yeah, it's good.
Do you know much about GoTenor?
Well, GoTenor is cool, but for me it's a bit proprietary. So the devices are proprietary, they're expensive, and they're very limited on bandwidth. It's you know, it's great, big mesh network where you can send like a transaction through, great. But I suppose maybe the reason in which they're so expensive is because of the distance in which they can cover. But when you're talking about these things being $1, like, you know, these being cheaper means that you can have like a much tighter mesh network with faster throughput, and you can send more information through it. So the plan for the mesh is to have, ultimately, is to have that broadcast layer and have that unicast layer with maybe some sort of hash cache scenario, so you can send a transaction for a very tiny amount through the mesh network, and then have that fee maybe scale up depending on how busy the mesh network is. But that's perfectly plausible. Like, it's not, I'm probably not the best person to do it, but it's a perfectly plausible concept, and for the right person, it shouldn't be too hard. Maybe I should try and rope Stepan into working on the mesh network thing as well if I can. So yeah, definitely worth checking out. Good, no more questions? Nope, okay. Cool, thank you.